Okay, we're beginning the third part of this chapter 15 um, lecture series, and we're going to talk about specific heat. Let me dismiss my image and begin our discussion of specific heat. Specific heat capacity is defined as the quantity of heat required to change the temperature of a unit mass of the substance by 1 degree Celsius. You can think of it as like thermal inertia. It's a resistance of a substance to change in temperature. Specific heat is essentially a measure of how thermally insensitive a substance is to the addition of energy. Um, the different substances have different thermal capacities for storing energy. Example, it takes about 2 minutes to raise the temperature of an iron pot of water to boiling temperature. It takes less than 1 minute to raise the temperature of the same quantity of water in a silver pot to boiling temperature. Um, so these numbers are not important. They're not listed anywhere in your book, but I have a table here. So an iron pot of water has a specific heat of 460 joules per kilogram per degree Celsius. And a silver has much lower, 234 joules per kilogram per degree C. So you can see that with the silver being lower, uh, the uh, it doesn't resist heating up as much. So aluminum has a specific heat of 921 joules per kilogram per degree Celsius. So that gives you an idea of why it takes 2 minutes uh, to raise the temperature in an iron pot of water as opposed to a silver pot, because the silver has a lower specific heat, so it'll warm up uh, quicker and warm up the water more quickly. Okay, equal masses of different materials require different quantities of heat to change their temperatures by a given amount. 1 gram of water requires 1 calorie of energy to raise the temperature 1 degree Celsius. 1 gram of iron requires 1/8 as much energy for the same temperature increase. Therefore, water absorbs more heat than iron for the same change in temperature. Water has a higher specific heat. How much higher? Well, iron, I said earlier, has a heat capacity of 460 joules per kilogram per degree Celsius. Water has a specific heat of 4,186. It has the highest specific heat in this table that I'm looking at. Um, so water is able to resist change in temperature uh, as compared to any of the metals. Um, so those numbers that I called out to you are not important. It's just for reference that I gave them. You don't have to memorize those for a test or a quiz or anything like that. Okay, mechanisms for absorbing heat. The increasing molecular jiggle raises the temperature. Remember, it's kinetic energy, 1/2 mv squared. So the molecular velocity increases, it raises the temperature. Increasing the internal vibration does not raise the temperature. Increasing the molecular rotation does not raise the temperature. Increasing the potential energy does not raise the temperature. Water has an especially high heat capacity. Like I said, 4,186 joules per kilogram per degree Celsius. Water molecules are adept at absorbing energy without increasing translational kinetic energy. Water has a higher capacity for storing energy than most other substances. So I used to go on missionary trips during spring break to Honduras, um, and you have to get used to taking cold showers because even if they have a big, with the little mission outpost that we stayed at, they had a big tank of water on the roof, and even though the sun is beating down on it, it doesn't raise the temperature very much. So you have to get used to taking um, cold showers. Uh, I didn't find them fun, but you get through it to do the job. Okay, the specific heat affects climate. For Europeans, the Atlantic Ocean current carries warm water northeast from the Caribbean regions and retains much of its internal energy long enough to reach the North Atlantic Ocean. Energy release is carried by westerly winds over the European continent. And we'll see that if you read the text, it affects the west coast. The waters coming in off the Pacific Ocean uh, affect the California and the west coast. Uh, the winds coming off the east coast affected also. So water has a great effect on our climate. Okay, specific heat affects climate. In the United States, winds in North America are mostly westerly. On the west coast, air moves from the Pacific Ocean to the land. In winter months, the ocean water is warmer than the air. Air blows over the warm water and then moves over the coastal regions. This produces a warm climate. On the East Coast, air moves from the land to the Atlantic Ocean. Land with lower specific heat capacity gets hot in the summer and cool in the winter. Okay. Which has the higher which has the higher specific heat capacity, water or land? Well, I just told you earlier that water has a specific heat of 4,000 of over 4,000 joules per kilogram per degree C. So the water is going to have the higher uh, specific heat capacity. A substance with small temperature changes for large heat changes has high specific heat capacity. Water takes much longer to heat up in the sunshine than does land. This difference is a major influence on climate. That's as I was saying in that compound that we stayed at in Honduras. Even though the water tank was on the roof, it took a long time to heat up. In fact, it was cold every day that we were at the compound. Um, and that's the end of part 3. So we'll end the lecture here.